All right, so you sent over some research about large language models.
LLMs.
Yeah, LLMs, exactly. This one, it's called GSM Symbolic, Understanding the Limitations of Mathematical Reasoning in Large Language Models. And I gotta say, it really makes you wonder what these AI models are actually capable of.
Yeah, everyone's talking about AI passing these standardized tests, solving these crazy complex problems. But this research, it asks a really interesting question. Are they actually understanding the math, or are they just like super memorizers, like picking up on patterns that honestly, even we might not see?
Okay, so break it down for me. Where does this research start?
So they started with this data set called GSM-8K.
GSM,
8K. Basically, it's a bunch of grade school math problems. And for a while now, this has been like the benchmark for figuring out how well LLMs handle math.
makes sense, right? Start with the basics, bit of
Yeah.
that foundation.
But here's the thing. If everyone's using the same test, are the LLMs actually learning the math, or are they just memorizing the answers? It's like if you studied for an exam by only looking at last year's questions.
Oh, you might get lucky, but you're probably not going to ace it.
Exactly. You got it. And that's what the researchers wanted to figure out. So they created their own benchmark called GSM Symbolic.
Okay, so what's different about this one? What makes it so special?
So imagine you take a math problem, right?
Yeah.
And you switch out the names and the numbers, but the actual math part, the logic, it all stays the same. That's what GSM Symbolic does.
Huh?
It lets researchers make endless versions of the same problem. No more memorizing the old data set. Now,
Mhm.
the LLMs, they have to actually solve the problem.
That's actually really clever. So it's like they're giving each LLM a brand new math test every single time.
Yeah, you got it.
Okay, so what'd they find? What happened when they started testing them like this?
Well, they found that even small changes, especially to the numbers in a problem, would totally throw some LLMs off.
Yeah.
Like their performance would just tank.
Wait, so changing, like Alice has 10 apples to Bob has 12 apples. That messed them up.
Yeah.
Seriously.
Yeah. What's interesting is they were better at handling changes to the names,
Hmm.
which, might mean they're latching onto those surface level details instead of actually getting the math behind it.
So they're better at changing names than numbers. That's
Yeah.
like saying, I understand Shakespeare because I can swap Romeo for Juliet, but I have no idea what they're actually saying.
Yeah,
It's all about the words, not the meaning.
exactly.
Mm-hmm.
And it makes you wonder, right? How are these LLMs actually processing information? It's not just about getting the right answer. It's about understanding why that answer is correct.
Right, because 10 apples, 12 apples, different amounts, sure, but they're still just quantities. It's all part of the bigger picture of that math problem. So what happened when they pushed it even further? They didn't just stop at changing names and numbers, did they?
No, you're right. They didn't stop there. They took it a step further with this thing called no-op. Yeah, basically they started throwing in totally random information into the problems.
Like what kind of information? Give me an example.
Okay, so say you've got a problem about, like, how many total kiwis someone has, right? And then they add in a line about them also having 5 smaller kiwis.
Okay.
It doesn't actually change the total number of kiwis. It's just extra stuff.
So like a distraction, basically. See if the LLMs can stay focused on the real problem.
Exactly. And the crazy thing is, adding these little irrelevant things, these no-ops, it caused some LLM's accuracy to totally plummet, like, in some cases, a 65% drop.
65%. Wow, that's a huge difference. So it's like they're so busy trying to use every single piece of information, they miss the bigger picture, the actual problem they're supposed to be solving.
Yeah.
They're not stopping to think, like, hold on, does this even matter?
It's like they're trying to put together a puzzle, but they're not even looking at the picture on the box.
Yeah.
Just trying to make all the pieces fit without actually understanding the whole picture.
Which is kind of unsettling if you think about it. If they're getting tripped up by basic math because of these irrelevant details, what happens when we start using them for way more complicated stuff? Like, imagine LLMs writing code or even diagnosing medical conditions.
Right, and that's a serious concern, right?
Yeah.
Imagine an LLM that's supposed to be diagnosing a patient,
Right.
and it gets stuck on some random detail from their medical history, something that has nothing to do with why they're there in the first place.
Right?
That could lead to a misdiagnosis, and that could have really serious consequences.
Because it's not just about crunching numbers or spitting out data, right? It's about understanding the context, the relevance. Like, you hear those stories about early facial recognition software misidentifying people because it was so focused on skin tone instead of actual facial features.
Yeah, exactly. And this research, it really highlights how important it is that we don't get ahead of ourselves.
Yeah.
We can't just keep throwing more and more data at LLMs and expect them to magically become, like, truly intelligent.
So it's not just about building bigger and bigger data sets.
It's about figuring out how they're learning, not just how much information we can cram into them. This study, it suggests that just scaling up the data, that might not be the answer. We need to figure out how to, encourage them to actually understand math, understand logic, not just recognize patterns on the surface.
Teach them to think critically, not just memorize.
Exactly.
Which is a whole different ballgame.
Yeah, it is.
And this research, it kind of makes you question, what does it even mean for AI to be intelligent?
Totally. Yeah, it really challenges a lot of assumptions about these models. Are they actually intelligent, or are they just really good at following instructions, just mimicking what we want to see?
It's exciting and kind of scary at the same time. We're on the edge of this AI revolution, but we still have so much work to do to make sure it actually benefits humanity, not just,
Right.
It creates a whole bunch of new problems.
It's a huge responsibility. This research is like a wake-up call,
Yeah.
The AI community, we need to be more upfront about the limitations of LLMs. We need to develop more robust and ethical approaches.
And maybe slow down the hype train a little bit.
Yeah.
Focus on building AI that actually understands the world, not just the data we feed it.
For sure.
I'm curious, though, how do different LLMs stack up against each other when you put them through these more intense tests?
Well, that's what's fascinating, right? They tested all sorts of different LLMs.
Okay.
And yeah, some did better than others, obviously. But they all kind of showed that same vulnerability to that irrelevant information.
Yeah.
And that difficulty actually going beyond what they were trained on.
So it's not just one company, one type of LLM.
Right.
It seems like it's a fundamental issue with where we're at right now, which makes this research even more important. We're getting this sneak peek behind the curtain of AI, and we still have a ways to go.
We've come a long way, that's for sure.
Oh, absolutely.
But we're still in those early stages. And this research, it just reminds us that we got to be thoughtful, about how we use LLMs in the real world.
Right, because we can get so caught up in the, wow, look what it can do, that we forget to ask.
Exactly.
Well, should it be doing that?
It's about finding that balance,
Uh-huh.
right? Pushing the boundaries, seeing what's possible, but also thinking about the consequences.
And being transparent, being open about what these LLMs, what they can't do, so we can actually talk about this stuff, about how we develop them, how we use them.
Yeah, absolutely.
This research is a great start, but it's really just the tip of the iceberg.
For sure. It's a call to action for everyone, really. Researchers, developers, even policymakers. We got to come together if we're going to build AI that actually makes things better.
AI that solves problems instead of creating a whole bunch of new ones.
Exactly.
AI that actually understands, not just imitates. Right.
Yeah.
But I think that's what I really hope our listeners take away from this.
Yeah, keep asking those tough questions. Keep pushing for transparency. The future of AI, it depends on it.
Well said. And on that note, I think we'll wrap things up here. But remember, the future of AI, it's not something that just happens to us. It's something we're all a part of building.
So stay curious, stay informed, stay engaged.
And we'll be back next time with another deep dive into the world of AI.